Welcome to Frequency Matters. This is a special edition. We welcome to the studio Preet Virk, Senior Vice President and General Manager of the Networking Business Unit at Macom. Welcome to the show.
Thank you.
We had John Croto, the CEO of Macom, on a little more than a year ago, and he kind of discussed the GAN strategy that was laid out by the company. And where do you stand with that now?
Yeah, thanks, Pat, for the opportunity to talk to you. As you know, Macom has been a very big advocate of the GAN technology. We believe the future of this technology in many, many applications is very, very bright. GAN is ideally suited right now from where we stand to replace LDMOS high power applications, wireless base stations being just one of them.
Right.
Another place where we think GAN can make inroads is as a replacement for GAS in the future. Since John talked to you last time, I'm happy to report to you that we have now customer validation data for our Gen 4 Macom Gann product, which we have been sampling to customers, and the results are very, very encouraging.
Great.
In summary, customers have validated the Macom Gann value proposition that John had put out, both from a technology perspective as well as from the Doherty implementations of the product. First step, which John had articulated, was for us to extract the cost out of the substrate. If you go back and look at some of the announcements we've made with our partners in this process, that is done. We have achieved a substrate at the right cost levels for GaN on silicon products. The second important step in this journey was to then transfer Macom's GaN process technology to large-scale foundries. And these foundries are, CMOS-like process, which is very suitable for our GaN on silicon products. We have accomplished that. And as a validation of that, we have put out product samples to our customers based on that process transfer to these foundries. And that is the product that I mentioned earlier that the customers have validated to check on the specs that we have been articulating as the value for our GaN on silicon. Last point in this that I'd like to make in terms of the progress is great products in this target application, especially in the base station application, where the customer base is very demanding, highly concentrated but very demanding, is the availability of an excellent team to support our customers as they transition from their current solutions to GaN on silicon. I am proud to say that we have the world's best teams now situated close to our customers, a team in China based in Shanghai, and another team in US. These teams have decades of application knowledge and experience in wireless base station PA design. And these teams are actually the ones who were instrumental many, many moons ago in the transition from bipolar to LDMOS.
Oh, right. So they have a lot of experience.
They have a lot of experience. They've been there, done that. And when we were looking to establish our teams, they had heard of the Macom Gann story. They validated it, believed in it, and they have now moved over to Macom and exited from their LDMOS-centric employers. These teams are on the front lines, helping us with the customer evaluations, extensive lab evaluations, and support. And they're also actually doing, based on the customer spec, Doherty designs in our engagement with customers. So a lot of process, extracted the cost out of the substrate, transferred the process, put out production candidate samples in our customer hands, and have the right team to support this transition.
Great. So how would you describe the maturity level and state of qualification with base station customers?
So the Gen 4 process is fully released to our foundry partners now. And again, the validation is the material coming out of that, those foundries is exactly what we are sampling to our customers. We will be disclosing more about our supply chain partners in the coming months, so I'll leave it at that. But again, going back to customer evaluation, the maturity claims by Macom have to be validated by the customers. And the customers have validated it. And again, the best proof point there is we are now engaged with tier 1 customers for real commercial radio designs. So as you know, in this industry, there's multiple steps you have to go through with the customer lab evaluations.
Right.
And then they say you are a candidate for designing on commercial radios. We have accomplished that milestone. And that, I believe, is a key milestone for Macom, and also, I think, a key milestone for the industry.
Right.
Where GaN is now ready. The maturity on technical specs, let me give you a few insights there. Our engagements so far with customers have been in the 1.8 to 3.8 gigahertz frequency bands. We believe that's the right sweet spot to start with the first wave of our products. We are showing greater than 70% efficiency and 19 dB of gain. And very, very importantly for the new radio designs, the larger channel bandwidth and the larger bandwidth support for the radios up to 200 megahertz, the so-called video bandwidth, we have supported that. The one very interesting and I believe a unique technology accomplishment that we have is our Macom Gen 4 GAN is the most DPD, digital pre-distortion, friendly product in the market today.
Wow, I didn't
The
know that.
linearity is very critical for our customers.
Yes, definitely.
As they move to higher frequency band and broader channel bandwidths. And that capability, that benefit to the customer comes from certain intellectual property that we have, which is patent protected. I believe this DPD-friendly, highly linearizable product capability will be one of the insurmountable challenges that the competitors are going to have to match us. In summary, we've released Gen 4. Customers have adopted the samples, done the validation, opened up commercial designs to us. We have also now, thanks to our foundry partners, which have CMOS-like process flows, and our packaging partners to be complete, can bring in LDMOS-like cost structures with silicon carbide-like performance, and then the linearity and DPDs above and beyond what silicon carbide can provide today. Last but not the least, some customers do their own Doherty designs. We're starting to see other customers actually want us to ship to them a Doherty design. So both symmetric and asymmetric Doherty. And we have the team now, as I mentioned earlier, that can actually, based on the customer spec, they are putting out Doherty designs for faster adoption for the customer base.
Oh, great. And so you did allude to some of the advantages of gallium nitride on silicon. How does it compare with some of the LDMOS current technology and GaN on silicon carbide?
Yeah, so as John has articulated multiple times, we believe GaN on silicon is a far superior technology than LDMOS and GaN on silicon carbide. So some of the capabilities obviously are above and beyond LDMOS, and then the others I'll explain to you are how they're better than silicon carbide. So power efficiency is extremely important. Our ability to provide 70% or higher power efficiency is key. I mentioned earlier 19 dB gain and video bandwidths up to 200 megahertz. Those are all better than LDMOS. There's also another element which is becoming key, which is a small form factor, given the advantages of GaN over LDMOS. So we can actually put out smaller footprint, smaller packages to give equivalent power, or alternatively, give you more power in a similar footprint.
Yeah, better power density.
Better power density, precisely. And this becomes more and more critical as the MIMO goes from massive MIMO to higher order MIMO. This will become even more critical as you go from transition to 4G to 5G. The packaging is also an important aspect. So we have a diverse package options for our customers, everything from a plastic, earless plastic, to ceramic. And that is also a key component of our portfolio. And again, going back to your comment on power density, it allows us to actually do some clever things with smaller packages.
Yeah, I've always been very impressed with your plastic packaging. You get up to 100 watts in
Yes,
plastic.
so I'll actually give you the very high end. We can actually deliver, not in plastic, but 700 watts in a single package. And that brings me to another important point. Thanks for mentioning that. There have been some myths in the industry around the thermal capabilities of GaN on silicon. Based on the material we've shipped to customers and the analysis both by us and our customers, that myth is unfounded, that competitor FUD is unfounded. And the proof point, again, going back to 700 watts in a single package is as good as anybody can deliver today. So we believe at operating temperatures, our thermal capabilities are as good as silicon carbide. Now, in addition to the linearity and the DPD-friendly aspect, which is above and beyond any silicon carbide supplier today, we also bring the cost and the capacity and the scale, which are missing in GaN on silicon carbide today. So when you compare with LDMOS and you compare with silicon carbide, we believe we have very, very clear differentiators, and we have raised the bar on what GaN on silicon can do in the industry.
Great. Yeah, that's always, I think, kind of been the last thing, was getting the cost down to LDMOS levels.
Yes, so the cost and the compact size are important for 4G. They are mission critical for 5G. So as you move to 5G, we believe Macom GaN on silicon is going to be the key enabler because of those capabilities that we just discussed to put out these massive MIMO applications.
Can you talk a little bit about your strategy in expanding into the base station market, and then also into some of the other important markets like RF energy and aerospace and defense?
Very, very, very good question, Pat. Let's look at GaN so far in base stations. which is only GaN on silicon carbide. It has penetrated, but it hasn't triggered the explosive adoption. And the reason, I believe, is cost.
Correct, yeah.
And supply chain inefficiencies and capacity. Tier 1 OEMs are very risk averse. They are very, very sensitive to capacity issues, supply chain issues, and also surge capacities. As you noticed over the last 4 to 6 years when LTE was being deployed, there's surges that come from AT&T adoption or Verizon adoption or China Mobile adoption. The ability for the supply chain to have that elastic capacity available can only come from CMOS-like processes.
Right.
So from an expansion strategy, Macom is ready, the customers are ready, and the customers, if I may say so, are actually desperate to get onto GaN on silicon. So the Macom Gen 4 product release resolves the barriers that existed for widespread GaN adoption in base stations. Having said that, we will also exploit the economies of scale that comes from us attacking adjacent markets like RF energy, like medical, industrial, and scientific applications, which will give us the economies of scale and the very, very high volumes, which then translates back into benefits for our base station customers. Additionally, in the base stations, we have already shipped, we are shipping to tier 1s, small signal, highly integrated, compact front-end modules. These front-end modules leverage Macom's legacy strengths. For example, we have high-power pin diodes, which Macom is well known for. We take those pin diodes and we combine them with best-in-class LNAs and integrated bias control. All these technologies are in different processes, and that again leverages Macom's strength of heterogeneous process packaging. And we are able to provide this as a front-end module for small signal to our base station customers. Again, important for 4G, mission critical for 5G. That sums up our overall base station expansion and beyond base stations.
Great. Sounds like you've really made a lot of progress quickly, and we really appreciate coming on the show today and talking to us about your GaN strategy, and we'll continue to follow how you progress.
Thank you for the opportunity. Appreciate it.